All right, so let's get going on this Mod 9 group test. Many of you, I'm hoping, will be paying careful attention here because you really want tomorrow's test grade to be something that you're not afraid of, right? Yes, say yes, Mrs. Franken. There we go. Okay, so Mod 9 group test. State all excluded values, all of them. So that means anything that starts off as an excluded value and anything that ends up as an excluded value. So from the beginning, I have an excluded value right there. What is it? N cannot equal what? Some of you say 2. Well, 2 times 2 is 4. That's not 0, not an issue. Some of you say 1. 2 times 1 is 2. That's not 0, not an issue. 0 is the issue right there because 2 times 0 is 0. What would the issue be here? 5, because 5 minus 5 is 0. So that's my beginning part. Now, if this was addition, subtraction, or multiplication, I would be done. But this is division. What does that mean? This is going to end up flipping. So what is a numerator currently will be a denominator at some point in the process of solving, right? So I also have to get excluded values from there. So if I were to snowflake that, I have negative 12 and positive 1. What would my two numbers be? 4 and negative 3. That gives me n plus 4 and n minus 3. What do I get from here? Negative 4, and from here, positive 3. So there are 4 excluded values in that problem. Okay? Again, if this was any other operation, I would not have to look at that numerator, but because it's division, I have to look at the numerator as well. Why do I not need to look at the numerator of the first fraction? Because in division, you don't flip the first fraction, you only flip the second one. Okay? Questions there? All right, 1 down, 9 to go. Some people freaked out here because this was a comma, and they were like, oh, what are we supposed to do? Well, you're not supposed to add, subtract, multiply, or divide. You're just supposed to identify the least common denominator, which means that the first thing you need to do is factor the denominators. So, what do these two things have in common? 5x, and what would be left inside? X plus 3. So, let's see, 5x squared plus 15x. Yep. Over here, the first thing I notice is that I can take out a 10. Do you notice that? And then I have x squared plus x minus 6, which I can snowflake. Negative 6 and 1, what would my two numbers be? 3 and 2, which one's negative? The 2. So this is really 10 and then x plus 3 and x minus 2. So, between 5x and 10, what has to be a part of my least common denominator? 10x. Between 5 and 10, 10 is the smallest number divisible by both 5 and 10. And since there's an x, I have to take that. Now, how many different parentheses do you see represented? 2. There are 3 parentheses total, 1, 2, 3, but only 2 of them, or there's only 2 different kinds of parentheses. There's an x plus 3, so that has to be included. And there's x minus 2, so that also has to be included. So my LCD is 10x, parentheses, x plus 3, parentheses, x minus 2. I'm sorry, one more time?
Why didn't you take the 5x?
Why didn't I take the 5x? Is 5x divisible by 10? 5x, is it divisible by 10? No. Stays as a fraction, right? But 10 is divisible by 5 ignoring the x, we got to take the x. But 10 is divisible by 5 because that takes away the fraction. Okay? Your LCD, a lot of people think least common denominator, and they get it confused with greatest common factor, because greatest makes you think it's going to be a bigger number, but it's actually a smaller number. Least common multiple, you are actually going to be counting by 5s, 5, 10, 15, 20, 25, and counting by 10s, 10, 20, 30, and you're looking for the smallest number that's on both lists. 10 would be the one that's on both lists. It's the smallest. Okay? So if you had a 3 and a 6, the LCD would be the 6. Okay? What if you had 5 and 20? 20 would be the smallest number that would be on both lists. What if you had 3 and 8? 24 would be the smallest number that both of them would have on their list, or that would be divisible by both. Okay? Again, if you need more help with the LCD, there is, I'm sure you could go onto YouTube and just search least common denominator. There are probably other teachers who have made videos and might explain it just slightly differently that helps it click a little bit better in your head. You can also look at the interactive student edition of the textbook online. Remember, it's got things where you can participate and try some problems out. Okay? I know that's one of the hardest parts of the test, and that is involved there, as well as in these two problems, and in these three problems, and kind of in this one also. So finding an LCD is kind of a big deal for this test. If you can't find an LCD, it's really going to be hard to get a decent score on this test. Okay? All right. When do I not need an LCD? When you are multiplying or dividing. Those are the only times you don't need an LCD. So why don't we do our multiplication and division ones first? Then we'll stick with all the LCD ones. So that's 5 and 6. Those are the only ones where I don't need a least common denominator. I do, however, need to factor everything I possibly can. So starting with the 3p minus 6, can I factor that? Take out a 3, what's left? P minus 2. On the bottom, p plus 9, can that be factored? Nope. So I'm going to put the p plus 9, and I'm going to put it in parentheses. That tells me I've already checked. It can't be factored. It can be canceled, though, if there's another p minus 9 somewhere. This one is multiplication. On the top, 18 plus 30. I'm sorry, 18p plus 30. What can I take out?
6.
A 6. What would be left inside? 3p plus 5. And then down here, let's see, I can take out a 3. If I take out a 3, that leaves me with 3p squared minus p minus 10, right? Can I factor this further? I think so. I need to check about snowflaking this. So what would go on the top? 3 times negative 10 is negative 30. And on the bottom, negative 1. What are two numbers that multiply to get negative 30 and add to get negative 1? 6 and 5, with the 6 being negative. Does it matter which one's negative? Yes, because if you made the 5 negative instead, you would get it adding up to positive 1, not negative 1. There's only one snowflake that fits. So let's see, what do I put on the top here? 3p and 3p, so I'm actually going to write it right below. I have the 3 out in front, and then 3p minus 6 will become what? P over negative 2, p minus 2. That should make sense, because if I'm thinking ahead, there's another p minus 2. That makes sense that they would maybe cancel. Perhaps my next parentheses might be a 3p plus 5. Oh, look, it is a 3p plus 5. Wink, wink. It's helpful to look at what you already have in there, because that can help you factor, because chances are something's going to cancel. So if that was my denominator instead of this guy, I have multiplication, so now I can make it one giant fraction. You know how I've been telling you can't cancel anything until you have one fraction? Well, now you have one fraction, because multiplication basically makes it into one fraction. So what matches from top to bottom? You can't cancel top to top or bottom to bottom. Has to be top to bottom. What can I cancel? 3p plus 5. I heard that one. What else can I cancel? P minus 2. Anything else? 3's. So I'm left with a 6 on top, and on the bottom, p plus 9. There were some groups that ended up with, I don't even know how to explain it. I think they multiplied 3p minus 6 times 18p plus 30. Like they FOILed all that out and did the same thing down here and ended up with this huge long polynomial on top and a huge long polynomial on the bottom and expected to be able to factor that. Very scary. Don't do that. That's going to put you in a situation where it's really hard. Okay, division. We talked about division a little bit when we talked about number 1. Excuse me. How do I solve a division problem? It's not going to stay like this, is it? No. It's going to, the first one's going to stay as it is, right? M squared plus 6m plus 8 over 4m plus 16, and I'll factor that in just a minute. But division is going to change to multiplication. And how do I flip this? It's not a fraction right now. How do I flip it? I put it over 1, so that when I flip it, it's 1 over m squared plus 4m plus 4. Now I have a problem just like the previous one, where I'm going to factor everything and then I'm going to make one giant fraction and start canceling. Do not start canceling until you have one fraction. In any problem, don't start canceling till then. All right, snowflake for this. I have 8 and 6. What are my two numbers? 4 and 2, and m. So I have m plus 4, m plus 2. Underneath, how does the 4m plus 16 factor? 4 parentheses, m plus 4, times 1 over, I got to snowflake this guy too, 4 on top, 4 on bottom. What are two numbers that multiply to get 4 and add to get 4? 2 and 2. So m plus 2 and m plus 2. Now in these kinds of problems, I would not write m plus 2 squared. I would write both of them out just so that it's easier to see what cancels and what doesn't. Am I ready for one fraction? Yes, everything is factored. So now that I have my one fraction, which turns all of this into multiplication, now I can start canceling. What do you see that cancels? M plus 4. What else? Okay. Now a lot of people went and then said, okay, I have a 4 left and I have an m plus 2 left. Well, that's correct. However, if you write your answer like this, there's a problem with it. What's the problem? There's no 1 on top. And if you don't write the 1 on top, what are you telling me? That this is on top. And it's over 1, right? So if this is left on the bottom, you have to put that numerator in there. You can leave a 1 off if it's on the denominator, but on the numerator it has to be there. Okay? Now let me explain that a little bit more. It's okay to write a number like that and a number like that. It doesn't change the meaning, right? But if I took this 1/2 and I wrote it like that, is that okay? No, because a half a pizza is way different than 2 full pizzas. So the 1 on top means something. 1 on the bottom, you can get rid of that and it doesn't change at all. So be careful about that. That's what was going on there. Okay? Any questions before we get to the LCD problems? Okay. Now, I want to address a couple of things that I saw when I was grading these. Number 1, I got people that ended up with equal signs in their answers here. Now, I understand the confusion, but keep in mind, there is a golden rule in mathematics that I wish was said more often. But if there is no equal sign in your problem, there is no equal sign in your answer. There is no equal sign here, so you are not looking for an answer like x equals 5. No equal sign. It can't just appear out of nowhere. Okay? The reverse of that, back here, we have problems that have equal signs. So guess what the converse of what I just said is? If there is an equal sign in the problem, there is an equal sign in your answer. Does that seem logical enough? So these ones you are looking for an answer like x equals 5. Okay? Now, if I'm not looking for an answer like x equals 5, I'm not looking to get denominators to cancel out. I'm just looking to get common denominators because fractions I can't add unless they have a common denominator. If you wanted to go back and look at the adding and subtracting, because I know a lot of people struggled here, it is your, 9.1 was the section that was in. So if you want to go back and look at the 9.1 notes, that's the section that it was in. Okay? Now, first thing I need to do is I need to get the LCD. Do you notice we gave you a little hint right here? No need to worry about excluded values here. Where do excluded values count? When there's an equal sign in the problem. No equal sign, no excluded values to worry about. Okay? So I need to start off by factoring the denominators. Can x minus 3 be factored? No. So I'm going to put it in parentheses just like I did wherever else it was down here. Saying that I've already checked, it can't be factored, I'm done with that denominator. Can I factor x squared minus 9? Yes. I can factor that into x plus 3, x minus 3. What do we call that? Difference of squares. So I'm going to cross out the x squared minus 9 because this is the form of the denominator we're going to focus on. Can I factor x plus 3? No. So I'm going to go ahead and put my parentheses there. What is my least common denominator? X plus 3, x minus 3. Doesn't matter if you put the minus 1 first and the plus 1 second, as long as your LCD has both of those parentheses in it. Okay? No numbers out front, so we don't need to worry about that. Now, here's where I write kind of like a skeleton of the problem. Do you see how the problem in general is a fraction plus another fraction minus another fraction? I'm going to write that. A fraction plus another fraction minus another fraction. And guess what I'm going to do? I'm going to put that least common denominator on all three of those fractions. So x plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. Now, I just need to unreduce these fractions so that they can be written with this least common denominator. Which fraction already has the LCD from the original problem? The 10x. That numerator does not need to change because the denominator doesn't change to get from there to there. This denominator has to change to get down here. What does it have to be multiplied by? X plus 3. So if I'm going to multiply the bottom by x plus 3, guess what? Top's got to be multiplied by x plus 3 also. So how can I write that? I'm going to write it as x times x plus 3. You okay with that? Again, I should be able to look at this fraction, and if I can mentally reduce this fraction, meaning if I can cancel out those x plus 3's, what's left over should be the original fraction, x over x minus 3. I'm just unreducing it. What do I need to multiply this denominator by? X minus 3. So multiplying the numerator by that gives me 5 parentheses x minus 3. Everyone okay with that? That's the hardest part of the problem. It should be downhill from here. Now, when I'm going to add and subtract fractions that have the same denominator, my result will also have that same denominator. I just can't start canceling anything until I have added all those numerators. Yes, sir?
I just want to know why you added x minus 3 to the 5.
Why I added the x minus 3. Oh, this denominator only had the x plus 3, so if I'm going to write it as a fraction with the denominator x plus 3, x minus 3, it was missing the x minus 3, wasn't it?
Yeah.
So I had to multiply by x minus 3 in order to get those denominators to match. So I have to multiply the numerator by the same thing.
Is that what you did over by the x?
Yes.
Plus five?
This one had the x minus 3, so I had to multiply by x plus 3. Okay? You okay with what I've got so far?
Yeah, I was just confused.
Okay. Now, I like taking a separate piece of paper here. You might not have a separate piece of paper, so let's just see what we've got. If I look at all of this right here, notice I'm taking those signs in the middle with it. I have x squared. I'm going to write it over here for a minute. X squared plus 3x plus 10x. Right? So far, so good? And then this would be a negative 5 times x is minus 5x. And negative 5 times negative 3 is positive 15. So if I were to combine like terms here, I have x squared. That's 13 minus 5 is plus 8x plus 15. Now, before I go and put that back in its spot as the numerator, I want to see if it can factor. I can check to see if it can factor now because I have literally taken all of the terms from all of the numerators and combined any like terms that there are. So let's see, can this factor? 15 and 8, 5 and 3. So what it really becomes is x plus 5 and x plus 3. Now that I'm down to one fraction, I can cancel. What can I cancel? So I'm left with x plus 5 over x minus 3. I can put the parentheses if I want to, but they're not necessary because there's nothing being multiplied on the top or the bottom. Can I cancel the x's? No, because if I couldn't cancel them there, I can't cancel them here. So that's just my answer right there. So? What? Okay, number 4. This 1 is supposed to be over 1. So let's see, can this factor, this denominator, can it factor? No. So I'm going to put it in parentheses. And none of the other denominators can factor either because they're just regular numbers. So let's talk about what our LCD is. Now, before I put these in parentheses, a lot of people want to try and group the 6 with the 3. But we can't because we have to keep in mind that k plus 3 is really in parentheses. Is 6 in parentheses? No, and it never would be in parentheses. So I have to include the 6, which would be outside of parentheses, and the k plus 3, which is in parentheses. That's my LCD right there. So now I'm going to write the problem, the fraction plus fraction plus fraction. Fraction plus fraction plus fraction. And what's the denominator I'm putting on all of these? 6 times k plus 3. So, looking at the first fraction, how do I get from k plus 3 to 6 times k plus 3? I multiply by 6. So the numerator, which is currently k minus 4, also something in parentheses, k minus 4, that also has to be multiplied by 6. Because remember, if I can mentally reduce that, I should end up with what the original fraction was. Okay, how about this one? 1 over 1. How do I get from 1 to 6 times k plus 3? I multiply by 6 times k plus 3. So what am I going to do to this guy? Multiply by 6 times k plus 3. Does this reduce to 1? So I did it right. And then this guy. How do I get from 6 to 6 times k plus 3? You multiply by what? K plus 3. So we got to do the same on the top. So I have 5 times k plus 3. So far, so good? So 3 fractions all have the same denominator. Now I can add them And my result will also be over that same denominator. Now, I got to look at what's going on in the numerators here. So let's do a little distributing. 6 times k is 6k. 6 times negative 4 is negative 24. This is a positive 6. If this was a minus sign, I would be treating this like a negative 6. Positive 6 times k is positive 6k. Positive 6 times positive 3 is 18. Positive 5, again, if this was a minus, I would be treating this like a negative 5. Times k is 5k. And positive 5 times 3 is positive 15. So let's see what we've got. 6k plus 6k is 12k plus 5k is 17k. Done with those guys. And negative 24 plus 18 plus 15. Negative 24 plus 18 plus 15 is positive 9. Can that be factored? So 17k plus 9 is the end. Some people tried to cancel the 9 with the 6. Well, if this is a plus sign and it couldn't be factored, it's technically in parentheses. So you can't cancel the 9 with the 6 because the 6 isn't in parentheses. I'm just done right there. Okay? So, front side of this test was worth 29 out of the 50 points. Or if you want to think about it percentage-wise, that's a 58 out of 100 is on the front side. Okay? All right, back side. Big hint right here. A table might be helpful. We did tables when we did this. This is section 9.3b. If you want to look back in the videos or the notes. We had a table, and we would say, okay, let's say Mike is on the top here, and we'll put Dan on the bottom. How long does it take Mike to complete one job? 10 minutes. How long does it take Dan to complete one job? We don't know, right? Find out how long it would take him to do it alone. So I'm just going to put X. That is always your first one. 1 over whatever number it is. 1 over whatever number it is. The next column is what? How long it takes them together. How long does it take them to do it together? 6 minutes. Just say 6. Now, what if I told you we were looking for how long it took them to do it together, and I gave you the individual times? Well, I would have 1 over 10 and 1 over whatever this is. You would have X here and here instead. All right? Now, what do I do in the last column? I multiply these two. 1 over 10 times 6 would be 6 over 10. Yes, you can reduce that if you want to. You don't have to, but you can. 1 over X times 6 would be 6 over X. So now how do I go from here and set up an equation? I take this plus this and set it equal to what? 1 full complete job. How do I solve this? I find the LCD. What would the LCD be? 10x. And since this has an equal sign, I'm going to multiply each one of these by the LCD over 1. So, I'm going to get a different color here. I'm going to multiply by 10x over 1, 10x over 1, 10x over 1. What cancels here? Because when I'm multiplying, remember, we can make our one giant fraction. So I can start canceling. What cancels? 10 and 10, and I'm left with 6x. When I make one giant fraction here, what cancels? X and x, so 6 times 10 is 60. And then 1 times 10x over 1 would be 10x. This should be a piece of cake at this point. Move your 6x to get your x's together. Divide by 4. And what does x equal? 15. Now, there is a chance on the test that it might not equal a nice number, in which case it will say in the instructions, round off to the nearest tenth, or round off to the nearest hundredth. Tenth would be 1 digit past the decimal place, hundredth would be 2 digits past the decimal place. Okay? Because it doesn't always turn out to be a nice number. So, what are we talking about? X equals 15 what?
15 minutes at a time.
Minutes. And that's representing the minutes of what? How long it would take Dan to wash the car by himself. Okay? Questions there? Yes?
I did something completely else, and I got 115.
1 over 15 wouldn't be the same.
Huh?
1 over 15 isn't the same. Same reason as this. 1 over 2 is not the same as 2. 1 over 15 is not the same as 15. 1 over 15 is saying 1/15 of a minute. That's a darn fast car wash. Yes?
Does the table count as points?
Yes. Yes, the table will count as points. That was the question. Yes, the table will count as points. Okay. All right. Solve each equation. We're now down to the equals ones. So we're going to have it equals in our answer, like x equals 5 or whatever it is. Remember to use excluded values to check for extraneous solutions. Does it say I need to state the excluded values? Does it say state excluded values? No. So I don't need to state what the excluded values are. I just need to check my answer against them to see if they cause any of my answers to drop out. Okay? Now, on Friday or Thursday when we took this, some people were saying, Mrs. Franken, you promised us there was going to be a no solution on here. I think this one's it. I never said there was going to be a no solution problem. I said there would be at least one extraneous solution. Just because you have an extraneous solution does not make the whole problem no solution. Because if you have two answers and one of them is extraneous, you still have one answer. It doesn't become no solution. Okay? It only becomes no solution if all the answers are extraneous. Yes?
How come your number 9 says minus and...
Good question. I will address that in just a minute. Okay? Let me start off with number 8. All right? Let's see. Can I factor this denominator? Because the first thing I got to do is find an LCD. So can I factor this? I think I can snowflake it. 8 and negative 6. What would my two numbers be? Negative 4 and negative 2. And n and n. So, this denominator I'm going to call n minus 4 and n minus 2. Can this denominator factor?
No.
No, so I'm going to put it in parentheses. And can this denominator factor?
No.
So I'm going to put it in parentheses. So what is my LCD? I see 4 parentheses, but how many different parentheses? 2. So that would be n minus 4 and n minus 2, and there's nothing in any denominator that's out in front. So that's my LCD. So what do I do at this point? I multiply each one by the LCD over 1. So this is where I write the n plus 2 over n minus 4, n minus 2, and I leave that strange space. Remember that from that lesson? And then minus 1 over n minus 4, leave that strange space, equals 3 over n minus 4, and I can fill in the strange space there. Now, before I multiply my denominators or my fractions by anything, are there any numerators that you think need to be factored or put in parentheses? N plus 2 needs to be put in parentheses. It can't be factored, so it just needs to stay being put in parentheses. Okay? So, let's see. I'm going to multiply each of these by n minus 4, n minus 2 over 1. These are the ones where I want the fractions to disappear. On the other side, without the equal sign, I don't need the fractions to disappear. Here's where I need them to disappear. N minus 4, N minus 2 over 1. N minus 4, N minus 2 over 1. So I can make each of these into a giant fraction and start canceling some stuff. What cancels here? N minus 4 and N minus 2, and I'm left with N plus 2. Do I need the parentheses around the N plus 2? No, because I'm not multiplying it by anything anymore. There's nothing left to multiply it. Now, I have a minus sign. What cancels here? So I have minus 1 times N minus 2, and I'm keeping that 1 so that I remember I have to distribute it after the minus sign. Equals. What cancels here? So I have 3 parentheses N minus 2. This is what I have to solve now. N plus 2 minus N plus 2 equals 3N minus 6. Yes, N minus N cancels out. A lot of people canceled out their 2's, and that created a big problem. 2 and 2 do not cancel out. They equal 4. What do I do now? Add 6 so that I can get that 3N by itself. Divide by 3. And N equals 10/3 cannot be reduced, so I leave it as 10/3. Now this is the part where the excluded values come in. I have to think back to the original problem. What were my excluded values? N could not equal what? 4 or 2? 4 or positive 2? As long as this is not 4 or positive 2, then I can box it as my answer. Okay, questions there? Yes.
Why couldn't you take off the ones?
Why couldn't I take off the what ones?
The
These guys?
no, the other one. Those two.
This one?
Yeah.
I could have taken off the one. I didn't have to write the one, but I can't take off the negative.
Oh,
So I could either have a negative out in front. I just wrote the 1 to remind myself that it's a negative 1 that I'm distributing. Okay, questions there? Okay. So, can this denominator be factored? Yes, I can take out an N and I'm left with N minus 1, correct? A lot of people wanted to treat this like a difference of squares and do N plus 1, N minus 1. It's not a difference of squares. It would be a difference of squares if it said N squared minus 1, but that's not what it says. So, not going to look at that form of the denominator, only this one. Can this denominator factor? No. So I'm going to put it in parentheses. This one doesn't have a denominator. Well, it does technically. It has a denominator of 1, but that's not going to affect my LCD. So let's talk really quick. Let's talk excluded values so that we've got them and we don't have to think about it later. What would my excluded value be from right here? N cannot equal 0. What's my other excluded value from these two? 1. So as long as I don't get 0 or 1, then I should be good. What is my LCD? N parentheses N minus 1. So I'm going to take this fraction, rewrite it, leave a strange space so that I can fill in what I need to, minus 1 over N minus 1. Again, leave a space so I can fill it in. Equals 1. I'll say 1 over 1 just for good measure. And what am I going to fill in these 3 awkward spaces with? The LCD over 1. LCD over 1. LCD over 1. Yes, question.
So anytime when the equation has like the equal sign, when we find the LCD, we also put it over 1.
Yes. Whereas when it doesn't have the equal sign, you're not trying to multiply by the LCD over 1. You're trying to rewrite the fractions so they all have the LCD and you can actually add them. Okay? Not worried about getting the fraction canceled out here. Want the fraction to cancel out back here so that I can actually solve it. Okay? So, making that into one giant fraction, what can cancel? N and n minus 1. So I'm left with 1 over 1. Does that mean I'm left with 0? I'm left with what? Minus. What have I got here? What cancels? So now I have 1n over 1, which is just n, equals, nothing cancels, so I have 1n times n minus 1, right? So 1 minus n equals n squared minus n. What do we know about what's going to happen every time I have an n squared? I have to get everything to that side and factor. Might be a snowflake factoring, might be taking out what they have in common, but I got to get it all over there. So let's start off by adding the n, because what happens? So I have 1 equals n squared. Now, right here, I could solve it. I could take the square root of both sides. If I took the square root of both sides, I would end up with positive and negative 1. The other way to get my answer is if I subtracted 1, I get 0 equals n squared minus 1. There is my difference of squares. And here's my n equals 1, n equals negative 1. So either way, you should end up with both positive 1 and negative 1. Whether you take the square root there, you have plus or minus, or whether you go down here. Now, were either of these my excluded values? 1 was excluded, wasn't it? So that means that's an extraneous solution. So my only answer is n equals negative 1. If I only had one answer and it canceled out, that's when I have no solution. But I could have two answers, one cancels out, and I end up with one answer still. Okay? All right, last problem. Now, x minus 2 doesn't have a denominator, does it? I could treat this as two separate fractions, or I could make life a little bit easier for me and just call it one fraction. So if I have 1, 3x, and x, what's my LCD? 3x. What's my excluded value? X can't equal 0. So I'm going to take this fraction, x minus 2 over 1, leave a space so I can multiply it, equals x squared plus 6x minus 7 over 3x, leave a space, minus 1 over x. And what am I going to put in those spaces? By the way, why didn't I factor that numerator? I don't need to, because I need to wait until I get here and combine all the like terms with the other numerators before factoring is an issue there. So I'm going to multiply all of these by 3x over 1, 3x over 1, 3x over 1. Now, this numerator over here, I need to treat it like it's in parentheses. So right here I have 3x, parentheses x minus 2. Here I have x squared plus 6x minus 7 minus 3. So let's see, 3x squared minus 6x equals x squared plus 6x minus 10. So now I'm going to get everything to the same side. I actually think I'm going to move everything to the left just so that I can keep that x squared positive. If your x squared is negative, it makes it hard to snowflake. So let's see, 3x squared minus x squared would give me 2x squared minus 6x equals 6x minus 10. I'm going to subtract 6x. That gives me 2x squared minus 12x equals negative 10. And I'm going to add 10. And now I have 2x squared minus 12x plus 10 equals 0. I'm going to take out a 2. Leaves me with x squared minus 6x plus 5. And I think I can snowflake that. Let's see. 5 and negative 6. What are my two numbers? Negative 5 and negative 1. I'm going to go ahead and finish this. So x minus 5 and x minus 1. There's no answer there because there's no x there. I have x equals 5, x equals 1. Neither of those are my excluded values, so they are both valid answers. Okay? All right, good luck.